Hey folks, good morning, good afternoon, good evening, good night from wherever you are, different time zones. Yes, it makes a lot of difference. So now I welcome all of you for this NLP workshop for precision medicine. There's a lot of hubbub which is going on behind the precision medicines. Whether it's all about you who have decided to work on this field, whether you are a data scientist, whether you are an engineer who has been working in the field of AI for quite a bit of time now, or else it can be anything. So now at the end of the day, what really matters, one such living entity working on getting the medicine back to that living entity itself. So now I'll just give you a brief intro on what this technology is all about. So precision medicine is one such technology where you have been working on involving genomics, proteomics, AI, machine learning, deep learning, data science, everything into one stack, where it's just allowing you in order to just give you that one insight of what might be the disease and what can be the diagnosis is all about. Today, the diagnosis is something which is more unique because people are using all these techniques in order to build something as a robust environment in order to give that real time approach and the real time analysis of what this disease is all about. So now, when I come to all these things, yes, it's going to be purely a fantabulous thing. So now let me just put this as a new application and let me start presenting my screen now so that it becomes application window. Yes, I am streaming it now. Yep, let me just go to that window. Let me just present it. I'll hide this. Thank you so much for Google Slides for giving me an opportunity to build slides online, else I would have lost it somehow. NLP for precision medicine is basically one such thing. The agenda for this event is basically I'll be giving you a brief insight on what NLP can be used in precision medicine. Next, I'll be going on in how to build a data set at the end of the day. Next, I'll be moving on in order to give you that slight approach in what this thing is all about. That means how can you analyze a text in order to give what this thing is, and how can you analyze genome in order to give what this thing is, and how can you actually implement the algorithms which are there in the colloquial on the normal deep learning machine learning, and how can you get that leverage out. Let me just give you a brief insight. Activation functions are from the wavelet functions. So now at the end of the day, when you look at something like that, it's going to be something humongous, because every time when you are looking at something, it's going to be something new. So make sure that you are just sturdy enough to withstand that newness which you're seeing at every given point of time. So now let's start it. What is an NLP? NLP is an interactive study between the computer's human language, which is natural language processing is equals to an computer science plus AI plus computational linguistics. That's you're dealing with ones and zeros. So now it makes a huge deal because it has to be called as in computational linguistics. So now some of the problem statements are basically this column is for you easy ones, medium ones, and the hard ones. So this is how I have defined it, and this actually works in order to give you a brief intro on what this technology is all about. Every day when you start working, it's a new thing. So now it's a new vibe which you are creating. So now you are not supposed to say, okay, I'm deep learning scientist, I can't work on text files now. It's madness because I too was the similar one because I was more fascinated about the technology called as computer vision. Now when you say me to do something in computer vision, yes, it's easy to some extent, but now when there is an involvement of something as and sequential data which is in a form of ones and zeros, at the end of the day it can be a text, it can be a JSON file, it can be anything. Yes, it makes me feel okay, I've not done anything now. So it should not be the reason why you are doing that. So now you are supposed to give your own approaches, you are supposed to give your own way in which things are working out. So now I give you an opportunity in order to get to know what this technology is all about. So now, why? Because when you think of a child, it requires education, it requires pet workers, family, everything. So in a similar fashion, NLP is filled with problem statement which is involving something as good as similar to building a baby from scratch. I can say something like, okay, to an extent where you can say, I've been working on these aspects, so now where can I get to know what's actually going on? So now at the end of the day, yeah, I can actually give you an example of your WhatsApp data being analyzed in the real time. WhatsApp data NLP. So yes, there are things which are available for you to learn what's actually going on. So emojify, all this work is there, so you can guys also get to know what is an emoji, everything all about it. So now what really makes it hard? All the things in machine learning plus some more. You see Google Translate, it just translates from one language to the other. See, detecting language, right? There's a feature called as detect language. So now when you think of such kind of an application, right, it makes sense because when you're building such kind of an application which is having a lot of biases based on the languages, based on the people who are working there, yes, it makes a lot of difference. So now language is one such barrier which you can think in NLP. Standard and the non-standard examples of using words. Am not, is not, as not is just one standard example of words set which is being given. But non-standard is this, and this is the truth. Annotation bottleneck, extraction of complex structured information beyond the sentence boundary. There is lot of insights that you can get from one line of data that you have captured, but your machines can be dumb enough to not to get that insight. So now what they did is they just need data at the end of the day. Thus all these factors which I've been saying, it makes a lot of sense. But are built for these? When you see problem statement, yes, there is problem statement, but they are being built for that. Simple sneaker. How many sneaker heads here? I just want to see in the chat. How many sneaker heads here? Yeah, there are 6 people watching. Anybody sneaker heads here? You can comment. Okay, I think probably there are. There are nothing that I can say about it. Sorry for it. Let me just present my screen. Yes, and there are some open problems which are available. So now at the end of the day, when you think of NLP as one such application, there are some open problems which are being designed just for you. So now when you think of such kind of an open statement which is being given out to the world, yes, you can use something for COVID-19 or something like that, tracking people. Yes, NLP has helped it. So algorithms are much beyond our reach. There is a simple use of probability can give you a lot and lot of insights on some data sets. So yeah, make sure that you get to know what are you working on in the real time. So now at the end of the day, it's all neural network. When you think of, okay, I'm working on something else here, I just need something, okay, fine. So now what is precision medicine all about? It's just this definition which can make it much more easier. See, there are ways in which you can actually give a personalized medicine for your patient which you have been seeing. Probably this is a new trend which we are seeing today. Cancer diagnosis also has seen lot and lot of success today. But now at the end of the day, there is something called as charming lashes, which is actually one such thing where everything has its own pros and cons. So now precision medicine also has its pros and cons. You know, there's a thin line between the problem statement where you can think wasted one third of the health, spending 1 trillion per year. That's actually the amount of money which is being used in order to give proper health for one third of the world. Today there is lot and lot of uh, pollution in the society. There is no way in which you can think of, okay, I'm not doing right here, I'm not doing right in eating my food, I'm not just breathing the best air, best quality air possible from me. At the end of the day, it's just that one thing which is actually making you spend that amount of money. It's not 1 trillion as a person spending per year, it's the entire population which we are thinking about. You know, top 20 drugs are 80% non-responsive, which is basically 80% of the people will not be able to respond to the drug which is being administered to the patient which we are seeing. So now, but we have one new disruption. You know, Martin Cooper, the person who invented the cell phone, had no clue that this technology will be something new. But yes, this technology is something new. At the end of the day, it's an all new level of application that you are trying to build. So now, when you think of what's a sneakerhead, Udaya Ravishankar, okay, fine. A sneakerhead is basically a person who is behind the sneakers. You know, shoes. You know, there are bots for the sneakers, you know, for copying it ka matlab you have to just be on the time to get it in retail, or else you have to go for the resale, which is like probably twice of, you know, sometimes twice of what the retail was all about. So yeah, let's just go on. And we have it one new disruption, that's your cell phone, an edge computer. At the end of the day, it makes lot of new features hopped inside everything that you're working. So now there's a new technology called as an edge computing, where everything is on mobile, which is moving, which has tight memory, less battery, less memory, and also low power. These devices work on low power. You don't work with your edge devices in such a way that, okay, to an extent where you can at least use it for 4 hours, but you can't use a light bulb for 4 hours with the same amount of battery, right? So this is how edge computings are making new changes. Why curing cancer is hard? A big question, but yet the question itself is filled with answers. Why cancer is hard? It's just filled with metastasized cells, where you can never predict it. It's just formed inside a human being at one given point of time, and now there's a new way of mutation which is happening all of the sudden. So it's impossible to predict such kind of an application. Cancer is not a single disease, it's just a process which happens. You know, when you go for chemotherapy, the entire cell which is focused on all the radiations gets burnt at the end of the day. Thus cancer patients who are taking chemotherapy is basically less immune to any of the changes which is going on in the world. So now cancer naturally resists treatment. You know, there are ways in which, when you are not psychologically stable in terms of becoming good enough back once again from your illness or the ailment which is being caused, anything, let it be cancer, let it be psychological, let it be medically induced. There are people who have taken medicines in a way like food, and people have suffered from Alzheimer's is one such new thing which is being seen in this new world. So yeah, you know, this is probably in 10 minutes or 20 minutes of intro, and I'll be going for the new ways in which you can think of how you can build a data set for this session will be based on the data set, and I'll be explaining you a little bit of code. So that's where the insights for the data sets comes into the picture. So just the genetic information being bored, because genetic information is just the way you can analyze where the mutations are going on. There are ways which it's just an inevitable cause. Cancer is just an inevitable. You can't really stop cancer from getting formed unless you don't have an healthy habit. Even sometimes people without any healthy habits, they survive. You know, it's the genetic pool or the genetic information which is being carried for quite a while now. You know, I'm fat but I'm not diabetic at the end of the day. So yeah, I have 22% body fat, which is humongous now. Had 14% body fat exactly 2 months before, so now I regret it. You know, I'll just move ahead. You know, becoming fat is also something which is new, because adipose tissues have something called as, they also are a part of regenerative medicine now these days. You know, they take the stem cells from the adipose tissue and they culture it and they induce it back as in stem cells. So there are chances where it gets rejected, but you know, adipose tissue is there in your body and it's actually giving you the stem cell. At the end of the day, probably being fat and getting thin probably will help you in getting that right cure now, because your body tends to start learning what it requires now. So now when we talk in terms of traditional approach has influenced us the same. Tumors are the originating organ. Now, it's just an organ which is there. There can be no separation when you do it. But there is something called as a SPECT scan and a PET scan, which has some radioisotopes which are induced. So now these work on the behavior of the cell. So now when you look at cancer cell behaving as something new, so now at the end of the day, when you look at cancer cell being formed, so now you can think about it, like where is it going wrong or what is it. So that's where scans come into the picture. So at the probably in the middle of this session, before going to the code, we will be seeing how to generate data set for the precision medicine. It's actually a vague approach which I'm giving in this part one, and I think part two will be there, and I'll be streaming it, I think probably next month end. No, not next month end, I think it will be in the month of March. And by the way, I just have to say one more thing. In the March, we have a session from Anirudh Kaul, and wonderful person in ML and recognized scientist in ML. So yes, we'll be getting him on March 13th at 10 a.m. to 11:30 a.m. IST. It will be a, it will be on the same platform, the YouTube, and it will be streamed on. It will be streamed through StreamYard. So yeah, that's how we'll be getting the things there. So when I say you this, I know it's not the way in which I have to make sure that you learn something. You know, imatinib is one of that drug which is actually a kind of a medication which is used for treatment of cancers. You know, this was actually not that uh, supportive to some people nowadays, but now also this is also giving some sort of a cure these days. So now when you think of it, it's just a drug at the end of the day which is working. So now there is something called as biomarkers which you can see. You know, when I said about the SPECT scan and a PET scan, you know, this is how things work. You know, there are biomarkers which have been given out from every aspect. You know, it can be breast cancer, it can be a lung cancer. There are different biomarkers which are seen in our body. So you know, that's how the behavior of the cell changes. That's where the SPECT and the PETs can come into the picture. And also there are some blood samples which can actually predict it. You know, Google come out with a multi-model prediction where just by your scan of the eye, it can predict whether you will get a heart attack or no heart attack, whether you have epithelial disorder or not. No, not epithelial, optoepithelial disorder, all these. So these are just biomarkers at the end of the day. They are nothing else. These just work fine as your medicine, which is being generated from your body. These are basically indicators of the diseases which have come out inside your body, not in the form of external entity. It's an internal entity at the end of the day. Why we haven't gone completely precise in precision medicine? Because there's a lot of confusion involved. Confusion to an extent, it's just filled with ambiguities. You know, it will be like I approach with this method, and if it will start working, and somebody will be having another approach and it also starts working. So there is a lot of ambiguity at the end of the day. Reason, our hope is still biomedical data at the end of the day. You know, when you can think of this is the set of biomedical data which you can think of. These are some of the open source and also readily available data sets where you can really work upon. There is something called as cancer image archive which I'll be going through in order to give you that brief understanding of what data sets will be. So now, and the game of the algorithm, you have to just perfect it in a fine way, because you have to be a fine-tuned algorithm engineer in order to give that right approach for your problem statement. So no, there is something called as PubMed, which is being running from lot and lot of people who really want to contribute to the world of science. So PubMed.gov is government is basically one such online platform where you can really get an access to all these kind of medical applications which you are trying to build. This is an archive basically where you can really think about, okay, I have this problem statement. Where can I find the best paper? To most of the cases, this can be most useful here. So now let's focus on the drug development. You know, I actually want to do drug development. You know, I will be also sharing my Eventbrite link for the drug development in the comment. So Udaya Ravishankar, okay. Oh, sorry, that's a previous comment. So it's an Eventbrite link for the drug development. I'll be giving you that link in the comments. So do check it out in order to get the brief insight what you want for your precision medicine and the drug development. So yeah, for the drug development, this is also by me. So yeah, this is how you are supposed to be doing, and this will be the one which I'll be using in order to give you the right approach which I really want. Precision medicine has been in quite a while now, and drug development I'll be doing it in the month of February or March. The date is on March 7th. Oh, sorry, I have a lot of events which have been listed. So the event will be on March 7th. So do join in order to get that brief insight on what the things are. So yeah, let's get it started, people. So now let's focus on drug development. Can we get the best solution for millions of combination of drug and millions of reaction products in days? It's impossible because there is an infinite amount of possibilities that you can. It's not possibilities, it's plausibilities at the end of the day. You can think of this reaction might happen in this way, but reaction can turn out into an adversary at the end of the day. That's where adverse drug reactions, ADRs, adverse drug reaction comes into the picture all of the sudden. So now let's just focus on one thing. We lose our desire to do the hard working, folks, and let's do the same smart work, because there is a requirement of hard work to some extent, but there is something called as in smart work which is also being required, because you are supposed to find solution in days. You will not get years and years of research, you will not get tons and tons of hardware resources if you are not working in any of the firms which are like Microsoft, Google, DeepMind. Yes, you are not accessible to such kind of an hardware. So now how? By thinking cancer to be solved, it can't be thought as cancer can be solved, because as I told, cancer tends to reject some sort of an drug, some sort of a treatment which you are trying to give for administering for a patient. It really makes a lot of difference. It really makes a lot of difference because people are working on different applications every day. So now it makes a lot of difference. So chronic diseases we will just predict and prevent. You can't really cure some sort of a chronic disease. Most of it you can't be solved, but I'm not making an open statement here, but it's basically what we have observed from years. You read any sort of a research paper, it says it is being predicted and prevented, and most of the time it's like, okay, it was supposed to be cured by then, but it's not getting cured, kind of approaches, or kind of in papers which you can see. I think probably there is a huge way in which research is going on in terms of chronic diseases. Probably this pandemic what we had experienced, probably that's also an one such thing which all the scientists, apolitical bodies just came into the picture, work day and night in order to give the most optimal solution today. At least we have the vaccine today. I think probably I have done a podcast with Peter Hollands. Peter Hollands is one such great personality where you can think of in order to get that precision medicine or the regenerative medicine going on. So that's where it makes lot and lot of difference. So to check it out in order to give that right approach for your problem statements if you are working on stem cells, just by building a machine for this purpose, make machines read or make machines learn. This is what you really do. In NLP, you actually make machines read something, whether it can be an OCR model which you have built and it starts reading the text which is being found, or else it can be trained to just learn from what we have to just train machines with little annotated data. Yes, it's just little annotated data. So now understand the complex semantic explanation beyond that specifically mentioned in the text. That's what I said. It's all about getting the insights. People, you need to learn how to get insights from your actual data. So that's where getting insights of your data makes a huge sense. So now NLP frameworks are using an interpreter. Yes, I'll be using Python now. So TensorFlow, Keras, sklearn, Python. Spacey NLTK. I'll be using sklearn mostly. Spacey, no, because I'll be using it in a part two. NLTK toolkit will be using, and these are the ways in which we'll be trying to build the model by using our data. Precision medicine has an enormous potential for positive impact for the human health. AI techniques such as an opportunity for health and a clinical research team. You can just think of HMMs, and you can just think of analyzing all these techniques and all these things. In the pharmaceutical industry, the notation of high throughput biological scenes such as next generation sequencing NGS can provide an information of pharmacogenomics related drug development, from biomarker discovery to the target assessment to the patient satisfaction. So now this webinar is all about decision making, computational, and all is. And to a fun fact, we are actually induced something called as music. Yes, there is an influence of music in this. Any musicians here who can play something as an instrument or anything, or so, you can just say in the comment, yes, we'll just give a shout out at the end of the day. That's what it is all about. So yeah, that's what it is. So now let's just get into the code. So let me just share one more window which I'll be using. So now, can you think of something like this, right? It's a huge and a humongous impact which this world has. So this is actually a precision medicine notebook which I'll be working on now. So these are the outputs which I got, and I just tried before the webinar. I just tried getting the collab thing running on the system. So yeah, that's what I actually did. I just wanted to get the collab thing running, but yeah, I didn't find the time. It was in my other notebook which I was creating. So yeah, that's where it all makes lot of difference in Kaggle. Yes, I was using Kaggle. So yeah, this is how I unzip it, and I just did it with all these things. So yeah, we'll just get some insights on code now, because I know most of the people here. Do you want me to do code, or else do you want me to do data set first? If you want me to do data set, I'll do the data set. If you want me to do code, I'll do the code. Any person who can reply now? Data set or code? Two options. I've given you two options. You can choose anything, data set or code. Any comments, people? It would be better if I can see anybody commenting here. So that will be much more happy. I'll be much more happy in order to get some more insights from you people. Anything as data sets or code? Okay, fine. I'll go with my choice. I'll go with the code. Fine. So now when you have this is the CBL score FM58A gene, which is being used variation in a class of the cancer which we are actually thinking about. This is actually a publicly available data set. You can just go there, grab it, and just start working. So this is how I have used NLTK for just getting the data sets wrangled, and all these things which I have used. Stop words have been used, and also this is the one way in which I try to get all the codes done. So this is how I started working, and this is where the things went on in order to get that NLP processing on. This is an index and a row, and the data of the text and the iter rows have been used, and this is how I was working on. So Evelians, you asked for the data set. Okay, I think I will do data set in a quite a while now. So yeah, and this is how I have done the code. I think I'll be sharing the PPT slides, the slides and the Google Colab notebook which I have developed here. So yeah, this is how the things are. So let's just go with the data set itself so that it becomes much more easier. So now let me just think. For a precision medicine, you need NLP data set, you need images, you need genetic information, no, flag fire, all these kind of data sets, everything is available. So yeah, let's just fast queue data set and all these things are available. Okay, let me just go with cancer image archive. So this is an archive where you actually get everything. So this is where it makes lot of difference. So getting data sets from here, yes, you can get your data sets. There are data sets which are available. So there's a REST API. If you want, you can access it. But I love downloading data sets, working on my local system. That's how I actually love to do. You know. Okay, so okay, people, I'll just give you the code. I'll give you everything in a full stack fashion. It's a long code, by the way. It's a very, very long code. Yeah, I think I'll give you a brief insights on the dataset, and I think probably in another half an hour or so, I think probably we can think about having a questionnaire Q&A so that it becomes much more easier. I think probably somebody has commented. No, no, sorry, nobody has actually given it. So yeah. Okay, so I'll just close it. So CIBIS is one such a collection of data set, and also there is 4D lung. Okay, let's just go with the 4D lung itself. So there's a data set available. Okay, count my image mobility, count by collection. Okay, fine. One collection is available for me. So there is a breast cancer data set which is available. So there is a breast cancer data set, Homo sapiens. So yeah, there are some open source data sets which are available here, so you can start downloading it. But all these are one thing. So let's just go with some other data source, probably vision data. Or I was searching for computer vision data sets. Probably we will get some very good data sets here. I think COVID-19 probably is the best thing. No, there is FaceMa. Yeah, I think I can use it. BIM COVID data set. Probably yes. I think this would probably work here. So yeah, let's just view the data set, what it's all about. No, I just went random. I didn't know what to actually do here. So I just went random and I started working on. Okay, now we have taken COVID-19 data set. So yeah, we can think of BIMCV. This is the one which we had, the standard, everything. There are GitHub repositories available. There are lot of papers which was actually written on this is also available in archive. You can just go for the ppt pd sorry, not the ppt PDF of it. You can just start working on. Okay, there is a data set here, and also there are image data sets here. So yeah, when we think of, fine, there is some GIF here which has not a GIF, I think so. I don't know that. So it's a very recent one, 2020, 6th month. 6th January, February, March, April, May, June. It's published in June. Yeah, June. Yeah, it's in June. BMR CV COVID-19 and largest downloaded data sets of transmitters, receivers, prescribed CT scan images of COVID-19 patients. Whoa, I never knew that until today. I think probably next workshop I'll be doing with this data. I think so. Yeah, no, think so. I'll do it. I'll do it. BMR CV COVID-19. Okay, download 1 plus 2 iterations. Okay, I think probably this is actually given. Oh, you need this thing. Fine. Affiliation. I'm in VishTU, so Vishwesvaraya Technological University, PTU. I'll just look at it. Yes. Oh man, what is wrong with this PTU? I'm affiliated to this university. No, I also check how to pass in the exam. No, I always do that. So I'll just copy it here, paste it here. Academic research. Yes, it's actually not an academic research, but yes, this is actually an personal research which I really want to do. Okay, come on, brother. You need to go faster. What is this? My net is slow today. Data bank. Yep. Public projects. I think so. Probably the data set is huge. I think they are going to send me there. If I get it, okay, fine. I'll do one thing. I'll just explain you with the data set which I got through the Kaggle. So Kaggle would be much more easier, I think so. So yeah, I think I should go with the Kaggle thing which I was working on. So MSK mask rendering. Okay, this is a cancer treatment data set which I had. So let me just go with that. Yes, it's 160 MB. So I think I can give the drive link there. Oh, I have to extract it because I'm not supposed to show, right? So if it wasn't collab, I think I could have used it. So let me just do one thing, let me just share my screen once again so that application window, desktop, yep, MSK, where are you, MSK? Yep, it's here. So now when you think of such kind of data set, there are it's an 7Z file, it's been extracted back and forth in action. So you need to install 7-zip, 7-zip here, extract file. So it's in CSV now. So it's in CSV file today. So let's just go for the Google Sheets and just run this. What's the insight of this data all about? So this is how the data sets come, and you just need to start working in order to give yourself the right understanding of what the things are going behind the system there. And also, you also need to work on what is going to be through all these systems. So yes, that's how your approach needs to be in order to get that brief understanding of what the things are working all about. When you just share an application, right, it's amazing. In StreamYard, you won't get that hide screen or something or so like that. So let's go with it. Data set, upload devices. I should go to the desktop, MSK rendering. Fine, it's already open. So now let's just go with the analysis of what this CSV data set is all about. So let me just go and share my screen once again. I think probably that would actually give you a lot of insights on what this technology is all about. I'll stop my share screen, come back to the StreamYard. Now an application window here. Stage 2. Yes, that's what I was looking for. So when you look at it, there is a variation, there is a gene, there is a variation of all these biomarkers and all these kind of application which you can think of. So all these, let's just go and one thing, there is a gene thing which has been given. So cancer genome, that's been analyzed here. There is a huge way in which genomics has come into the picture here. So oh yep, thought I had changed that. So this is how humongous a cancer image data set would be. It's 986. I'm not joking. It's all about the correlation that you want to get. This is a test data which we are analyzing. So when you look at this gene and this genomic pattern which you have been seeing, so whether it's a cancer or no cancer, it's a huge data set, right? So gene and the variation of the genes. So it makes a lot of sense. So now let's just go back to our screen of where we had the code. So wait, where did you get the MSK dataset open source? No, it's actually in Kaggle. It's actually in Kaggle. You guys can just go there. and just get that data set. It starts working for you all. It's asked by the Evelina. Sorry for pronouncing your name very wrong. If it's wrong, by the way, you know, where did you get MSK datasets open source? I'm not saying it's an open source. It's a Kaggle competition which was hosted. It's basically done there. Can you show us the data for precision medicine that requires NLP? Yes, that was actually one of the data sets which we had used, and also there is an test data which was being used. And Udaya Ravishankar, that's what is, yeah, it's all about. So that's where it is. So now let's just hop into the code. So that let's just not waste time and let's just hop into the code. Yes, I should share my screen back there. And yep. Now this is how there is a lot and lot of test variations which we saw, and a lot of things. This is how the bits and the bytes of data were being analyzed and everything. So this is the thing. So any Q&A, I think probably, let me not waste the time. Let me just go for the Q&A. Any questions that you want to ask? Guys, ask me any questions. It's no big deal now. So any questions that you guys want to ask me? Okay, I will also share you one of the paper which is actually an worm, kind of a swarm intelligence kind of a thing. Yes, can fruit fly learn how to embed words? This will be the link. I'll be posting it here so you guys can just get to know what's actually the thing which is happening in NLP today. So yeah, anything that you guys want to ask me, I'm open for the doubts. I'm absolutely open for the doubts. You guys can ask me anything. Can you show us the precision medicines that is requires NLP? I can't show you the precision medicines because I'm not a doctor at the end of the day. I can just show you some of the examples which we just tried working on. I've just worked on the same DNN architecture there. That's the code. So yeah, anything that you guys want to share? Anything? Yeah, I think I can give you my LinkedIn. I think probably LinkedIn would be better way in order to get the communication done. Actually, this is actually my first time on working on NLP. I've never worked on NLP before. I've never worked on NLP before. So this is my actually the first time that I'm working on NLP. So any doubts that you guys can ask me now. So this is my LinkedIn. So connect with me there so that it will become much more easier for you guys to start working. I think probably I can share you the link for the dataset also. It's a personalized medicine data set which is being there. So you guys can just go there, get the data. I think I'm sharing you the link which is there. So yeah, sorry for my quality of lectures. This is the link for the data set. You guys can just go there, just start working there. All the things which we just talked, it's all there. Everybody have written the kernel. You can just get to know what's actually happening inside the kernel and you can start working. So yeah, have you worked on CNN? Yes, convolution neural network. I've worked on images but never on an NLP data set till now. So that's what it is all about. Yes, so Evelina, I think I cleared your doubt here. Yep. Anything else? Okay. Evelina asked, where do you get? I think I didn't answer that question. Okay, fine. I'll answer it. It's from the Kaggle. It's open source. It's in the Kaggle. So, any other questions, folks? I think 6 people are watching. I think probably should have any doubts at the end of the day. You guys can connect me through LinkedIn. I think LinkedIn would be better. I'll be waiting for another 5 minutes. So, any doubts? Please do say, have you worked on the same thing? No other new thing. Okay, fine. Fine. Then let's just end the broadcast then. I think I was sleep deprived for quite a long time now. So yeah, that would be better if I just go on and sleep today. Or else just ask me some doubts, it will actually energize me and I just go have a good sleep today or something. Okay, fine. Okay, people, thank you so much for attending this Pi and AI event, Bangalore chapters event, which I am actually happy to give. It's basically that one way in which you can get a chance in order to learn what you really require. NLP has been one such thing which I was working on. So, yeah, NLP is not actually my research forte. So, precision medicine was one such thing which actually wanted me to work on and on something called as an NLP. So yeah, that's how I started working. So NL. So Evelina asked, "Have you worked on CNN?" Evelina, sorry to say that CNN is my food. If I don't love it, I probably might never get my food. So yeah, stay home, stay safe, happy learning people. So meet you on the next event which we are doing. Drug development, which will be on March 7th. So yeah, meet you on those days. And yeah, thank you so much for staying uh, for a long time on this workshop, listening to me, just allowing me to share my knowledge. And thank you so much, people. Thank you, one and all present.